delighted to be here at the user group session today. It's a pleasure to be presenting to you. We've been spending a lot of time over the years with Ken Graziano, who I know is well known to many of you, and I'm delighted to sort of throw up a bit of a provocative topic, sort of why Data Vault won't work long term without end-to-end DataOps. And maybe as we go through this, you'll see that maybe it's not just as provocative as it sounds whenever we first put it up. So just to introduce ourselves, my name is Justin Munn. I'm CEO of DataOps, and we've got with us Guy Adams, who's our CTO as well. Both long history in data, certainly myself, the last 20-25 years. Guy, as you'll see whenever he comes on, has spent the last 25 years actually in the software development world, and so only the last two and a half years in the data world. So I think a lot of what we're going to talk about and a lot of what we'll learn today is just the benefit of his 25 years in that software development world and what he saw whenever he came over into the data world, and why maybe the data world doesn't have to be just as different as it has been over the last 20 years. So we've got hopefully a pretty good agenda for you today. We're going to talk about just a quick intro in terms of why DataOps and what it is and how we see it and what our perspective is on it. Where that fits and where Data Vault fits into it, and our view as to the perspective on terms of where that fits within overall pipelines. We're actually going to show you some live stuff. So yeah, no chance anything can go wrong, I'm sure. But yeah, we're going to show you some live stuff. We're going to do some technical demos, and we're going to show some automation of pipelines and different elements of it. And we're going to bring in there Data Vault and specifically DBT Vault, which we've done an awful lot of integration. It's a fantastic tool that Neil and his team have been building, and we do an awful lot of work with it now. We've embedded it into the core system. We'll then hopefully answer the question, and maybe what we've seen before that is a lot of what goes to answering that question as to why we believe Data Vault or DataOps is essential to long-term success of DataOps. We've got questions at the end, but if there are questions as they come through, hopefully Neil and the team will be collating those. But really, if you've got anything, poke us, explore us, and get an understanding. Challenge us on anything that we put up. So look, just to get into that in terms of why DataOps. Well, all of you will be experienced people in the data world, and you'll know the data platforms now and for the last 20 years and for the foreseeable future are pretty complicated things. And from what we've seen, and certainly my experience over the last 20 years being in this world, very, very manual, lots of manual things going on, lots of tools from many, many different vendors that are employed to the different parts of different elements of these overall pipelines. And so one of the challenges that we've got is how, that creates immense challenges on data teams. It creates immense challenges in building environments, immense challenges in terms of data, the trust that stakeholders have in the data that flows through all of this very complicated sort of data platform. We actually inherently know what the answer to that problem is, and it's quite simply automation. It's automation of everything. That's what we see it as. It's automation of the calls to the ingestion pipelines. It's the automation of the modeling and the transformation. It's the automation of those continual processes to build new features and deploy them into production. It's also for us the automation of other key elements of it, the automation of the environment build, being able to automate the build of not just production environments, but dev and test and QA at the push of a button, automation of documentation, automation of grants and masking and security and who's got access to what, extremely important in the world that we live in today with the PII and GDPR. And then the automation of the generation of all of the audit trails that surrounds all of these solutions. So we solve this whole area of automation in terms of some of these challenges sort of 20 years ago in the software development environment. And I guess one of the key things and the key questions that we arrived at this at when we started this a couple of years ago was, how do we take those battle-hardened principles for the last 20 years in DevOps, and how do we build, test, and deploy data environments in the same way that we build software environments? And for that, we actually stepped back from it for a while, and and we looked at it from a philosophical perspective, and this was a lot where a lot of the benefit of Guy's 25 years in software development really came to it, but also spending time with Kent Graziano, with Mike Ferguson, who many of you may know, with Wayne Eckerson, and many other people, talking about really what way should we be delivering data. And there's a site out there, DataOps.live. Feel free to go and look at it. But it talks about not building data platforms anymore. It talks about building data products and just treating everything else as an engine to be able to deliver that. We've encapsulated that in DataOps for Dummies, and feel free to go to our website to draw that down. When after that we sort of said, right, well, okay, well, now we need to encapsulate this into a technology platform. And if we just look very briefly at what we're going to see today and some of the things that we're going to share, we make no apologies for the fact that we work on Snowflake. We've been working with Snowflake for many years now. Long users and long evangelists of it. We believe it's brilliant. There's some very key elements within the platform that actually make DataOps and the way in which we need to deliver data possible. DataOps is, Snowflake is that core platform. There are, of course, many tools, as we said, involved in the ecosystem around that sort of data fabric layer and moving data in and out of Snowflake and manipulating data within Snowflake, Fivetran, Matillion, many of which you'll have heard of, including DBT Vault for a lot of DBT modeling and transformation. And we sit, and where we sit as an orchestration layer that sits over the top of that. So if we drill into that a little bit more, just understand what that means. It means really the orchestration and the management of code and configuration. And we sit at the back of that with a Git repository that allows us to effectively manage all of these different things: pipeline definitions, orchestration configurations, the definitions of an environment. And Guy will talk a little bit about that, especially our new declarative approach to the way in which we build environments. Definitions of tests and regression tests, of life cycles, code. So all of these elements that we're currently trying to manage today, bringing that in and managing that within one repository. And the real purpose of that is to service the users and the actors that are really engaged in that, the people on the left of the screen, the data engineers, the data scientists, so that they can interact with and build this code and configuration in the same way they build code and configuration in any other environment. With feature branches, with merge requests, where there's full governance around the whole process of it. We provide lots of features inside the platform, which you'll see some of today, around scheduling, alerting, orchestration. But ultimately what we're doing is building these data pipelines on the right, these data pipelines that are sort of environment aware. And if we expose and look inside one of those data pipelines a little bit more, what you'll see is the sort of things that you would expect to see in a data pipeline. And maybe some of the things that maybe you hope to see but haven't seen before. So really all of the features to be able to build target environments, so build databases, build schemas, to automate the creation of all of the objects in your environments, to orchestrate external tools and external capabilities, whether it be Informatica or Talent or Matillion or Stitch that may be running within data environments, to build and bring in data, automate modeling, automate transformation that could be run by within our own modeling transformation, which is based on DBT and enhanced, or automate Matillion, Talent, and various other solutions around that. Big message you'll hear us talk about today is automated testing, and you'll hear us talk about that continually as critical to the way in which we build data platforms. But finally, then, we think about the communication of what we've got, then it's the automated build of documentation and the sharing of that documentation, either directly or through data catalogs. So those are what we see as the core tenets, and there are lots of capabilities which I won't go in that we see within the platform. And ultimately, we build data pipelines that go and get data and build and clone databases, that extract data from core systems, that maybe run governance and checks, that start to build models. And this is really the T in ELT. Run testing, although testing we say should be incorporated at every element and every stage within these processes, and then generate the documentation that is relevant to those. So that's what we see generally, and that's what we talk about when we say what is DataOps and what is it all about and why we need it. To bring it into more the context of today and think about what we're talking about, if we think of Data Vault and the impact of Data Vault on that, you know, I've been following Data Vault since 2016, but I don't profess to be any sort of an expert like many of the people on this session today. But you know, some of our observations is, you know, if you look at the approach in which Data Vault takes, and Data Vault is taking an approach of taking a lot of this data in, and then automating the modeling of the data. And the approach it takes the modeling data results in the generation of quite a large number of objects within the database. So a significantly large number of objects, and maybe more than we might find in other approaches. And then whenever you add to that, then the bringing in of the business Data Vault layer, the information delivery layer, we're adding to that even more objects and even more moving parts effectively to the overall system. So all of these need to be managed, needed to be automated, need to be orchestrated through the process. And you know, the more moving parts, the more risk that we've got within the system, and the more that we need to automate and to check it. And that's you know our view on it. But then when we extend that a little bit further and we start to think of Data Vault, we think of Data Vault as just one part of the overall pipeline. You know, just a focus within the transform part of the overall pipeline. And there are so many more elements that need to be automated within standard data pipelines. There's the automation, as we say, of the environment management, the automation of the prep and the ingestion of those data, the automation of security and enforcement of security practices and integration and secrets management, the monitoring, the alerting, the automated regression testing, you know, the automation of the build of data catalogs and logs and documentation. So, you know, there are, you know, the fact that we maybe have a Data Vault design pattern does not remove any of the challenges that we have in any normal data pipeline. The challenges with missing data, with incorrect data, with transformations that go wrong, with how we test batches of changes together, how we build and test environments, and how we embed regression testing into every element of it. So that's sort of our view in terms of where, you know, as important as Data Vault is and what it delivers, it is a component part of those end-to-end data pipelines. And what I'm going to do now is hand over to Guy just to talk through some of the ways in which we handle it and why and how we build Data Vault into our overall end-to-end DataOps pipelines. So Guy, let me hand over to you.
Okay, thanks, Justin. Let me just take the screen share. You see my screen okay?
Yep.
Great. Okay. So I'm going to pick up the story where kind of Justin left off, and actually I love this diagram because it really kind of illustrates the points that that Justin was talking about. You know, even at this level where we've only got sort of 6 boxes across the top, you know, it's clear that there is a lot going on. So what I want to start at is just look at the simplest version. You know, if we just wanted to build a data pipeline to get some very simple data and build out a Data Vault model using dbt Vault, what does that look like? So I'm going to start out with looking at that in a DataOps context, so something relatively simple, and then I'm going to kind of build back out of that and say, okay, what does it mean when we start adding in all of the other things that are needed? So I'm going to spend hopefully most of my time in the browser doing this stuff live. So this is our DataOps platform. Let me zoom in a little bit so you maybe see it a bit better. Here we go. So I don't have time to kind of give a full run through of the entire platform. Justin mentioned it's Git based, so everything we do is built around, you know, branches and, you know, everything in the platform, the definitions of the pipelines, the jobs, the tests, the logic, the transformations, the documentation, the orchestration, everything is just built into files in a directory structure. So when I look later and we look at, you know, Fivetran and Matillion and Python and secrets management and Stitch and SQL and Talend and thoughts and all these things, these are all just jobs that are, you know, simple jobs that are defined here as YAML files. We bring them together in these pipeline files and we execute them. And I'm going to look at 3 today. I'm going to look at a very basic implementation of a Data Vault model. Then I'm going to look at a slightly more complete one. And then I'm going to look at the final stage, which is what happens when we open this out to what we would call a reasonable enterprise grade DataOps pipeline. So before I get into looking at the first pipeline, just to show you some things that you might be familiar with, this is a demonstration project which shows hundreds of different things, and Data Vault modeling is just one of them. So there's lots of other stuff in here that isn't relevant. This is an absolutely enormous project, but the bits under Data Vault are bits that you will hopefully recognize. You know, I start out with the definitions of the of some source data. If you're in any way familiar with DBT Vault, this will be very familiar to you because we're essentially just using the standard demo project. So all of our DBT Vault definitions of how we build our hub tables, how we build our links, our satellites, and so on. All we've done here is add a few little bits and pieces, which we'll come on to in a minute, about testing and how we do testing. We've also built onto this just a trivial model to show how we move from that raw data vault into a business vault and ultimately into an information delivery mart. So I would have all of this in my repository. I'd be doing branches on it. One of the reasons I do branches mostly for two reasons. First of all, is concurrent development. We have customers with literally hundreds of developers all working on features independently, and they all need their own safe sandboxes to do it. But also for environment management. And it's one of the most important parts of DataOps is when I run a pipeline, that pipeline is environment aware based on a branch. If I run a master pipeline, I will populate a production database. And I'm going to kind of skip all the way to the end and show what this looks like inside Snowflake. So here we are. This is the Demo 5 project. So my master branch is building this database, the DataOps Demo 5 prod, when you can see a bunch of Data Vault stuff in here, which we're going to go and build. But you're going to see a QA environment, there's a dev environment, and there's even feature branch environment. So as an individual engineer, I can go and create my own branch dedicated for me and the work I'm doing, and I can have that build in a very cheap, very fast way, a complete sandbox environment inside Snowflake. So that environment management piece, where we have essentially a Git branch for all of our changes that are specific to us, and then a feature branch database inside Snowflake that ties up to that, is incredibly powerful for agility. It allows developers and engineers to be so much faster because they can go away, develop things quickly without any chance of harming anybody else or damaging anything in production. So let's go and look at some pipelines. I've actually got a pipeline running at the moment. I set it off when Justin started talking, so it's running away in the background, and we'll go and look at that one in a minute. But in true demo style, here's a couple I ran a few hours ago, and we can see the different flavors here. So I'm going to start out looking at this Data Vault Basic. So this is the simplest kind of possible pipeline that you could build. And it really just manifests the different stages. So build raw is essentially just grab some TPC data and materialize it into some tables. Then we build some staging models. Then we go away and build our hubs, our links, and our satellites, and our transactional links. Then we build a simple data vault, a business data vault from that, and finally information delivery. So each one of these is just executing a part of that overall process. And obviously the contents that you would have in here will be radically different depending on who you are. And some people will in turn want to subdivide these things down further. But a big part of this is splitting these things into small, manageable, containable blocks and allowing them to run in sequence. And you'll see why we make them run this way in a minute, because right now I could have run all this in a single job and it would have made no difference at all. But when we start introducing testing, you'll see why we break it up this way. Just to show you some things that you will be familiar with, if I drill into any of these, you'll start seeing outputs. If you've ever used DBT or DBT Vault, you'll be very familiar with these. So our transform runner, what we baked into DataOps, includes an enhanced version of DBT with a whole bunch of modifications, and we can talk about those later. But it also then includes the latest version of the DBT Vault libraries, which allows us to build that. So, as a customer, I don't have to include anything. I just specify a few models and I go and run it. And the runner that executes this has got all of the required dependencies and versions and libraries all built in. So this is my basic pipeline. When I run that, it's going to populate some set of tables. I'm going to get my raw data. I'm going to get my main Vault files or my main Vault tables and views if I've chosen to materialize as views. I'm going to get a business Vault, and this is a trivial. This has only got one table in, a customer's table, and ultimately my information delivery model, which I've just materialized as a customer's view. But that's the net result. That's what you get when you execute this pipeline. And I can then schedule this pipeline to run every hour, every day, every 10 minutes. I can run different parts of the pipeline at different frequencies. And when we start looking at a full or more realistic pipeline, you'll see where some of that becomes relevant. So I said, this is the really simplistic bit. Let's move on to the next stage, just to mention testing. And automated testing for us, and for me in particular, is in many ways the key piece. It's the missing link. I came from the software world, where automated testing is something we've been doing for 20 years. I came into the data world where I was dealing with multi-billion-dollar global companies, and I would ask them how they do automated testing, or how they test their changes before they release them. And they just look at me blankly and say, well, our users tell us if there's something wrong. In the software world, we got away from using our business users as testers 20 years ago, and yet in the data world, that is still very, very prevalent. And if you want to achieve anything close to meaningful data ops, automated testing is one of the absolute linchpins, one of the absolute cornerstones of that. So let me look at a slightly enhanced pipeline here. It's got all the same building blocks as we had before, but we'll start seeing some new stuff interspersed here. And the main thing we'll see interspersed is these testing jobs. So a lot of customers ask me when they're designing their pipelines, when should I do testing? And the answer, it sounds a little bit glib, is pretty straightforward. You test every time something might go wrong. That's pretty obvious. So this effectively, which is mirroring our ingestion, if I've just ingested a bunch of new data, or new data has been pushed into my data platform, pushed into Snowflake, why don't I test it? If I'm expecting to get 100 million sales records pushed in and I got 2, there's no point in moving on and refreshing a whole bunch of hubs and satellite tables, because I know that it's junk. There's no point in moving any further. In fact, I probably stand a good chance of doing some damage by doing that, because I'm going to be ingesting or moving bad data through the system. Whereas actually, if I know that the data I've pulled in is bad, I want to stop there and find out what's gone wrong. So we recommend testing after you've ingested data, and then we recommend testing multiple stages through transforming it. So I've built my raw data vault, so let me run a bunch of tests against that. Then I've built my business data vault and run some tests against that. Finally, I build my information delivery model and I run some final tests against that. And ultimately, if all of this stuff works, then I make it available to my business users. But that's the key piece here, is this automated testing in the pipeline will stop if something breaks. If the data doesn't meet the requirements I've laid down, the pipeline will stop. And you can change the behavior, but by default, the pipeline will stop, and it prevents bad data getting into the hands of my business users. So that's the real value of automated testing. And we don't do this once a day. We don't do this once a week. We do this every pipeline run. Every single time you move new data through the system, you rerun a set of tests to make sure that everything is still good. And we've got customers now running these pipelines with 5,000 or 6,000 tests, and they're running those every half an hour, because they've got new data every half hour. Their business users are making multi-million-dollar decisions against that data. And yeah, it costs them a few dollars every time they run it. But Snowflake's Elastic Compute takes care of the processing resources. It's pretty cost effective, and they'd rather pay a few dollars an hour and make sure their business users have got great quality, provable quality data than hope, which is the other strategy. So this is kind of the second pipeline. The other thing that this pipeline has, I will go back and look at it here. Actually, I ran a slightly newer one. There's one job at the end of it, which is to generate documentation. We have a pretty strong philosophical view around documentation. Back in the software world, 20 years ago, we used to build complicated architecture documents, and then we build our software. And we've stopped doing that for one simple reason. The only thing you could ever guarantee when you picked up a software architecture document was it's wrong, it's out of date. If the first line of code has been written, this document is already wrong. And people spend their entire lives dramatically failing keeping those up to date. The software world turned it around and said, we're not going to document what we might build. We're going to document what we have built, and we're going to do that by making our documentation automatically. We're going to stick metadata into our code, meta information into our code, and every time we run a CI/CD pipeline, we're going to generate a new set of complete documentation that documents our internal code and our APIs and everything else. But it's built from the code, and therefore it can't be wrong. And if you're familiar with DBT docs, this will look familiar, because that's exactly the principle behind DBT docs, and that's what we embed here. So every time we run this, we go and generate and attach to every pipeline a complete set of the documentation about all the data that got landed, where it got landed, and how we moved it through the system. So this will be familiar to many of you. We've made, this is a slightly enhanced version of this, but it's based on DBT docs. So it shows you what we had in our project. So this is some of the DBT Vault stuff in here. What we had manifested inside Snowflake. So these are the tables and the schemas that we saw actually inside Snowflake. But what it also gives you is this great top-level lineage view showing how all of the information has flowed through the system. So on the left-hand side, we've got our ingestion tables. So this is where we dropped data in, whether we're using direct ingestion, whether we're using Matillion or Stitch or Fivetran or Talender Informatica, it doesn't matter. But this is where the ingestion process finishes and where the transformation process starts. And then this is showing the transformation process through. So if we look at something like, go and look at maybe something like, we'll trace part of this through the system. It's not a good one because it doesn't have a huge amount in. But yeah, from here I can basically see all of the different work. In fact, there's a good one here in terms of reuse. So one of the things that we talk about a lot when customers are building this, and again, we've got customers with thousands of models here, is following software development principles. A big part of DataOps is not just the tooling and technology, it's the principles and philosophies. And almost all of these are inherited from the software world, and we try and keep all of the things that work well in the software world. We only add on the bits that we need to add on for data. And Justin mentioned this a little bit, DataOps is not trying to invent something new. DataOps, or true DataOps, is trying to say, let's take everything that's great about software and infrastructure as code, CI/CD, and DevOps. Let's take everything that's brilliant and carry on using it, and let's add on the extra bits that we need to work for data. But principles like dry, don't repeat yourself, are hugely important. When you see customers who produce a SQL view with 9 joins and a whole bunch of logic, say, well, why don't you break that down into smaller blocks? It's easier to develop, it's easier to test, it's easier to debug, it's easier to document, but it's also more reusable. When you do a small 2 or 3-way join, there's a good chance that someone else is going to come along later and want to use that little bit of it. If you've just done all that work in one model, in one big SQL file, if someone tries to reuse that, they're just going to be copying and pasting your code. Now you've got massive repetition and all of the maintenance and technical debt stuff that comes with it. So the way that you apply this stuff, the way that you build this stuff, the philosophies and the best practices are as important as the technology. So anyway, that's kind of automated documentation and something that we build at the end of every pipeline. That was a slightly enhanced version of the pipeline, but it's still only showing the data vault part of it. So I've got my pipeline, all those test results got aggregated up here so I can drill down and find out the results of all the tests that were done at different times. But what I want to look at now is what happens when we take a step back. So if I switch back to my slide a minute, we've been through this. When we stop focusing on just this transform bit and this data vault bit and we widen it out, what does a complete end-to-end pipeline need to look like to meet enterprise requirements? And there's a lot to it. So the pipeline that I'm going to look at now will be quite a big step forward. Everything that we saw before is still in here. So my build raw, my raw testing, my building, my staging, my building, my hubs and my links and my satellites and so on. But what we'll see is there's a ton of other stuff around it. And all of this stuff exists for a reason. And all of this stuff is stuff that we've got customers using in production environments today. So I can't go into all of these. I don't have time, but I'm going to go through some of the key points of this pipeline and really explain to you what they mean, what they do, and how they add to the overall pipeline. And to the original kind of theme of this, nothing I'm talking about here is unique to Data Vault. Everything we're talking about here is something that needs to be done no matter what data warehouse architecture we're looking at. So if we look at something simple at the start, load secrets. Nobody today wants to store any credentials in text files or configuration files or anything else. Everybody wants to use an enterprise secrets manager, AWS Secrets Manager, Azure Key Vault, HashiCorp Vault, something like that. Most of the tools in the data ecosystem don't support that, including DBT. So how do we solve that? Well, we build the secrets manager integration into our pipelines, so we can go away to all these enterprise secrets managers. We can get those secrets out at runtime, and then we can inject them into the Snowflake connectors. We can inject them into Data Vault. We can inject them into Stitch or Talend or whatever other tool we need to. So essentially, just with one simple step here, we effectively secrets manager enable all of the tools in the data ecosystem. So that's a kind of an initial step. Then we move on to some orchestration and preparation. We're actually preparing 2 things here. The first one is data prep. So there's a lot of more and more people are moving to direct Snowflake ingestion. They've got CSV files or semi-structured files, and they're essentially orchestrating them into Snowflake directly. And that's what some of these jobs here are just effectively an orchestrated copy into. but there's a lot of customers who have data that's nearly the right shape to go into Snowflake. Maybe it's got a few extra header rows. Maybe it needs some metadata added or removed. Maybe it's nearly JSON, but not quite. Maybe it's an Excel file, not a CSV file. It's close, but it's not something that Snowflake will accept. So we've developed some very simple data prep capabilities that just take data that's nearly right to go into Snowflake and manipulate it so it can be ingested directly. The other piece we do here, and it's probably the most important single job in the whole pipeline, is the Snowflake object lifecycle. This is essentially, if you're familiar with infrastructure as code and Terraform and things like that, this is infrastructure as code for Snowflake. So inside a repository, and I'll just show you a little bit how this looks, we define every aspect of our warehouses, our users, our shares, our roles, our resource monitors, our databases, our schemas, ingestion tables, views, masking policies. Every part of Snowflake that isn't the tables and views created by the modeling and transformation created by DBT is defined here, and it's defined in a declarative way. So I don't have to create table statements and alter table statements or grant. I simply say what I want it to look like, who I want to have access to it, and what level of access, and I run the pipeline. And the job of the pipeline is always the same. It will look at the target environment, it'll look at the target Snowflake system, it will look at the configuration here, and it will make Snowflake look like this YAML file. Whether it might be there's nothing to do, it might be it has to build everything, or it might be it has to go through and just do very careful alters to modify one parameter. But this gives us not just schema management for the tables, but it gives us infrastructure as code management for absolutely everything inside Snowflake. So this is a hugely important job. This basically means that from everything we go on to in here, we can be sure that we've got all of the right infrastructural elements inside Snowflake set up in the way we want them to be, that we can actually then start passing data through. Then we move on to ingestion, which is obviously a major part of any data platform. We've got to get the data in there. Usually this is done through orchestrating a third-party tool, Fivetran, Stitch, Matillion, Talon, something like that. But more and more we are seeing people to move to a direct ingestion. So they're producing CSV files, JSON files, XML files, Parquet files, and just orchestrating them straight into Snowflake. Once we got the data ingested, a lot of it's what we talked about. So we test that data. We do some more transformations. We might page out to an external system to do some enrichment. We might do some data stewardship. We might have a bit of Python code. We had a customer a couple of weeks ago who halfway through their transform process wanted to go out to the YouTube API and grab a whole bunch of metadata about some YouTube videos and enrich that and put that back into Snowflake. But it could only happen in the middle of the pipeline because they had to do a bunch of analysis to work out which videos they need to grab that for. So they put an advanced processing step somewhere in the middle of the pipeline. Then we've got more testing. Then we've got more transformations. The testing methodologies we use don't have to be the ones built into DataOps. We support now a variety of testing technologies. An interesting one that's coming on the market now is SodaSQL, which has some really nice characteristics, not just about data testing, but more and more they're moving into data profiling. Assuming everything up to this point has worked successfully and all my tests have passed, I'm now going to publish that data. So everything up to this point has been preparing everything, but only if everything up to this point has succeeded do I then publish it to my business users. I may even then go ahead and do a little bit more testing, just as a final validation. I've published it to my business users, but let me pretend to be a business user and go and see what they're seeing and make sure that it's valid, make sure, maybe I connected a different role and make sure that the analysts are seeing all the stuff they should see, or the data scientists are seeing all the stuff that they should see. And then once all the functional data processing is finished, then we move on to some sort of more meta stuff. So we've already looked at one step of that, which is generating documentation. But we also push a whole bunch of our own metadata about the models and the pipeline logs into Snowflake itself. We're doing more and more integrating with data catalogs. So if you think about it, the traditional model for a data catalog is I'll connect to Snowflake or I'll connect to my data warehouse. I'll scrape all of the tables and views and things like that, schemas and databases. But that's really showing the end state. That's showing what you get looking at this. But there's an enormous amount of rich meta information that's been built up over this pipeline. Where did we get data from? What test did we apply to it? What technology loaded it? How did we transform it? What test did we do in the meantime? What enrichment happened to it? How did we, where did we put slowly changing dimensions onto it? And so on and so on and so on. This is all incredibly valuable meta information that you just can't get from looking at the end result. So the people who are more sophisticated in the data cataloging space are saying, well, yeah, I want to look at Snowflake, I want to look at my target and get that information, but I then want to grab a whole bunch of information from the data pipeline itself, all the meta information that's been built up through this process. I want to suck that into and I want to join all that information together because that gives me the richest view of it. And when you think about it, from a data catalog facing a business user, I'm a business user about to make an important decision. What's the most valuable thing I'd like to know about that data? If I could look and see when was it last updated, maybe how much data was added, but what tests were run against that data and did they pass, that gives me a huge amount more confidence about the decision I'm going to make, because I can see proactively that data is good. And that's where we move from the world of data quality, which is checking ourselves that the data is good, to data assurance, where we're actually proving to our users proactively. We're not just saying, hey, yeah, we ran some tests, the data is good. We are giving them the information themselves to look at that and say, yes, the information is good. We assure that by giving you information about what tests we ran and what the results were. And then finally, at the end of it, we're starting to move into some sort of, how we improve our own internal stuff for DataOps. So what is my test coverage? It's all great having testing phases, but if I'm not testing most of my stuff, or if my testing is very sparse, then the testing phases are only worth the tests that you've configured in them. So things like monitoring and managing test coverage is important. You start moving into the world of kind of stylization and linting, and are we following best practice and things like that. So after I've completed all the functional work of the pipeline, it's a good opportunity to go and say, hey, is there any housekeeping to be done? Yeah, everything's passed, but if everything's passed because I've only got one test for 1,000 models, that doesn't tell me that much. I should look at the end of this pipeline and say, right, I need to go away and create some stories in my backlog and go and add some deeper testing to address some of my technical debt. So appreciate I've gone through an enormous amount of what is really an enterprise level DataOps pipeline in a short period of time, but hopefully what you take away from this is DataOps is entirely modeling layer agnostic. It doesn't matter whether you're using Data Vault or any other data warehouse architecture. You can use all of them. You can use all of them simultaneously. You can use any combination of them. They're all supported by the modeling and transformation part of this system, but the stuff that you build up before that and the stuff that you add after that are absolutely critical, as Justin said, to making a true end-to-end data pipeline. And that's really kind of coming back to this. If we want to get this true data pipeline, it isn't just a few boxes in the middle. We've got to have an awful lot of things as in addition to that.